You know, there is absolutely nothing worse in this line of work than fishing a cable through 50 feet of conduit, sealing up the wall, and getting just a black screen.
Or that awful digital snow.
Exactly. That flickering mess.
It's the installer's nightmare. And really, it's just physics. Copper is fine for, 1080p. But when you try to shove 32 gigabits of data down a long copper wire, resistance just wins. The signal falls apart.
Which brings us to today's subject. We're looking at the Kramer CLS-AOCDP UF-98. It claims to solve that exact distance problem by, well, basically cheating physics.
It's a 98-foot DisplayPort cable that promises flawless 8K video.
But the spec sheet calls it a hybrid cable. What does that actually mean here?
That's the whole secret. The hybrid part is key. If you were to strip this thing open, and please, at this price, don't, you'd find 4 strands of multi-mode optical fiber running right alongside 8 copper wires.
Wait a minute, glass fiber inside a flexible cable? Isn't that just asking for it to snap the second you try to pull it through a wall?
You'd think so, but that's the engineering magic. The fiber does the heavy lifting for the high-speed stuff, so the actual video data. That's how you get DisplayPort 1.4 compliance and that full 8K resolution at 60 Hz over such a long distance with, and this is crucial, 0 signal loss. Light just doesn't have the same resistance issues as electricity.
So the copper is just along for the ride.
Not entirely. The copper handles the low-speed signals, the handshake between the source and the display, and of course the power. By splitting the duties, they can hit high bitrate 3, HBR3.
And HBR3 isn't just a marketing buzzword here, is it? That's the actual standard you need for raw, uncompressed 8K.
Precisely. Without it, you're stuck with compression or chroma subsampling, and that kind of defeats the whole purpose of having an 8K display in the first place. This cable makes sure the full 32.4 GBps of bandwidth actually arrives at the screen.
Okay, let's talk about the active part in the name. When I see active optical on a long cable, I immediately start looking for a wall outlet or a USB port near the display to power it.
The power brick problem.
Yeah, and it's a real headache.
That's the old way. This Kramer unit is incredibly efficient. It draws less than half a watt per end.
So it's completely parasitic. It just sips the power it needs right from the DisplayPort connector on the video card.
It does. And keeping that power draw low is so important. Some of the cheaper active cables try to pull too much voltage, and it can actually destabilize the whole connection.
Yeah.
By staying under that half a watt threshold, it stays well within the port standard. It's truly plug and play, just like a normal passive cable.
And all of that tech is squeezed into a 4.8 millimeter jacket. That's thinner than most of the standard HDMI cables I've got lying around here.
The thinness helps with the bend radius. It's about 48 millimeters, but for the pros listening, the jacket material is probably the bigger deal. It's LSHF.
Low smoke, halogen-free. That sounds like a safety feature, but isn't that a legal code requirement for a lot of commercial installations?
It is, absolutely. If you're running cable in plenum spaces where air circulates in a commercial building, you often can't legally use standard PVC jackets.
Because in a fire, that plastic just pumps out toxic smoke.
Exactly. This LSHF rating means it's safe and, more importantly, legal for that kind of professional infrastructure.
So you've got this industrial-grade fiber, gold-plated connectors to prevent corrosion, and a jacket that meets building codes. I'm guessing this doesn't come cheap.
It is an investment, yeah. The list price is around $550, but you can usually find it closer to $440.
Ouch. Nearly $500 for a single cable. That feels like a tough sell for, say, a home theater setup.
For a home setup, maybe, but think about it from a pro's perspective. If you're installing a video wall or a medical imaging display that costs $10,000, $20,000, do you really want the whole system to fail because you tried to save a few $100 on the link?
That makes sense. You're paying for the 25 kilograms of pulling strength so it doesn't break in the wall, and just the peace of mind that the signal is actually going to get there.
It's insurance. It makes sure your expensive infrastructure isn't the bottleneck.
So to wrap this up, we're not really talking about cables in the old sense anymore, are we? This is basically a self-powered fiber optic transmission system that just looks like a wire.
That's a perfect way to put it. The line between a simple accessory and complex hardware is getting very, very blurry.
It really makes you wonder, if a wire is now an active computer accessory doing its own signal processing, how long until the cable itself is doing more work than the screen it's plugged into? Are we going to need to install firmware updates for our DisplayPort cables?
Let's not give them any ideas.
That's it for this deep dive. Check your connections, and we'll see you in the next one.